Well, hello there. Happy Friday to you. It is May 29th, 2020. And today we're going to try to look at the real basics, at least, of a concept called stoichiometry. I always kind of enjoyed stoichiometry. It's just, it's a very logical, mathematical thing that, just kind of, I don't know, it's kind of relaxing to do some math. So what is stoichiometry? Really, some of the calculations that we've already been doing, those are stoichiometry. When we've done our mole conversions, that's a type of stoichiometry. Stoichiometry refers to quantitative calculations based on chemical formulas and or equations. Okay, and so we've been doing formula stoichiometry. Now we're going to do a little bit of equation stoichiometry. Isn't that a fun word? Stoichiometry. It's just fun to say. Stoichiometry, oh, it's great. All right, so here's what we're going to work with. How many grams of oxygen can be produced by decomposing 57.92 grams of potassium chlorate? Now, had we had a little more time in class and been able to function a little bit more normally, I would have hoped you would be at the point right now where you could read that statement and write an equation. Realistically, I don't think you're likely there unless you've been really reading and working on your own beyond what I've been assigning. So, I'm going to give you the equation. And if we look at it, see it says how many grams of oxygen can be produced, so we know that that's a product. And we're decomposing potassium chlorate. So potassium chlorate is what we start with, and we're going to rip it apart, and we'd have to have some other background knowledge to know that when you rip that apart, you're going to get these things. Now, I didn't balance the equation yet. I want you to balance it right now. Hope you're done. Okay, there we go. 2, 2, and 3. Make it all balanced. So now we're ready to do the calculation. We cannot touch a stoichiometry calculation until you have a balanced chemical equation. Because if your equation, if you have formulas written wrong, if you have balancing wrong, then you're just going to be doing a calculation based on wrong numbers. So you have to make sure that you have a correct equation. What I like to do is I like to identify what I'm looking for and what I'm starting with on my equation. So this says how many grams of oxygen. So right there is oxygen. Now, you say, well, that's got oxygen, but see, that compound is potassium chlorate. That's not oxygen. There's oxygen atoms in it, but that's potassium chlorate. That is oxygen. And I'm looking for it, so I'm going to put X over the top of that, and I'm going to put a G to remind myself that I'm looking for grams and not something else. And what else do we know? Here's an amount of potassium chlorate. We're going to decompose 57.92 grams. So here's my potassium chlorate. I'm going to just write 57.92 grams. So I know I'm trying to get from there to that value. All right, let me draw up. Here's going to be my work line. This was the quantity I was given. So I'm going to start with that. 57.92 grams KClO3. And I know it seems like a pain to write down the substance, but in this calculation, you're going to be dealing with multiple substances. And so you have to write down what substance your numbers associate with. Okay? Now, in order to do this calculation, we're going to have to use something called a mole ratio. And a mole ratio comes from a balanced chemical equation. Now, we could have had a mole ratio in a formula too, right? Within the formula, there's 1 potassium for every 1 chlorine. That's a mole ratio of 1 to 1. In this formula, for 1 potassium, there's 3 oxygen. That's a ratio of 1 to 3. What I'm looking at here is the mole ratio of quantities, of the overall substances in the equation. See, for every 2 of these that I react, I produce 3 of those. So if I were talking about individual molecules, for every 2 of these, I'd produce 3 of those. If I produced 20 of these, or reacted 20 of these, I'd get 30 of these. 2,000 of these would give 3,000 of these. 2 moles of these gives 3 moles of those. So there's my relationship between these 2 substances, my given and my unknown. It's the mole ratio. The problem is, I didn't start with moles. So what do you think we got to do? Let's change that to moles. So what we do, and I should have had a periodic table handy. Give me a second. I don't have a periodic table. Alright, I grabbed the periodic table, and unfortunately I grabbed one that's really hard for my old eyes to read, but we'll get it through. I need the molar mass of that potassium chlorate. So that means I've got to add up 1 potassium, and potassium is 39.10. My table has 39.098, so that's what I'm going to use. 39.098 plus 1 chlorine, 35.453, plus 3 oxygen, so 3 times 15.999. Now, you may have the periodic table I handed out in class has those numbers rounded to the 100th, so that's a little bit different. All right, so based on what I had, I've got 122.548. That'd be grams per mole. Now, if you look at this, if I want grams to cross off, I got to write this on the bottom. 122.548 grams of KClO3 in every mole of KClO3. So if I do that much, grams would cross off, and I'm now on moles of potassium chlorate. So once I've got moles of potassium chlorate, now I can use this mole ratio. For every 2 of these, I produce 3 of these. This comes from the balanced equation. Now, since potassium chlorate is on top, I want to put it on the bottom. For every 2 moles of KClO3, I produce 3 moles of oxygen. Whatever label, whatever substance, I want that substance to cross off. I want to be canceling anything that's related to my original substance and replace it with something that's related to my other substance. And the relationship I had was 2 of these produces 3 of these. I can cross off moles. Right now, I'm in moles of oxygen. So I have a quantity of oxygen if I do this calculation, except the problem asks me to get a mass of oxygen. So I gotta do one more step. Okay? I gotta look up what's the molar mass of oxygen. Well, it's 2 oxygen atoms. So I got 15.999 times 2, 31.998 grams of oxygen per mole of oxygen. Yeah, you look at this first part here. To get from grams to moles, I had to divide by the molar mass. To get from moles to grams, I had to multiply by the molar mass, because now these cross off. So if you look at my labels, everything crossed off but grams of oxygen. So all I got to do is my math. 57.92 divided by 122.54 divided by 2, times 3. Does it matter that I did that out of order? It really doesn't, so long as I made sure I divided by this one and multiplied by that one. And then multiply by 31.998 equals And I'm going to think about, does it make sense? Yes, I think my answer makes sense. How many sig figs? 4. Yeah. 4 sig figs. So 22.69. Alright, so I guess if I felt our room was a little low on oxygen and I wanted to produce a little bit more oxygen for us, I could take some potassium chlorate, and if I had 57.92 grams of potassium chlorate and I entirely decomposed it, I could produce an extra 22.69 grams of oxygen for our room. Or we're better off just letting the plants take care of that for us. We got to take care of the plants, they'll take care of us. Okay, so here's a breakdown. Remember, I've been trying to show you conversions with maps. Well, so here's kind of the map of the process. In a mole, or in a stoichiometry problem, we have some substance A, and then we're trying to calculate something about substance B. So if I have a mass of A, I want to convert that to moles of A. Once I'm in moles, then I can use the mole ratio from the balanced equation to convert to moles of B. And then if I'm in moles of B, I could use the molar mass of B to go back to mass. Okay? What if, instead of starting out with the mass of A, I started with the moles of A? Well, then you can just skip that step. What if I asked you for the final answer in moles? Well, then you skip that step. The one that you would love to get is, what if I started you with moles and asked you to end with moles? That's the easiest one. I mean, think about this. If I said, hey, how many moles of potassium chloride would be produced if I react 4 moles of potassium chlorate? And you just say, well, if I got 4 moles of this, and every 2 moles gives you 2 moles, so 4 moles will give us 4 moles. Just that easy. We can just look at that ratio. All right, so let's try one more. How many grams of aluminum would need to react with copper 2 chloride in order to produce 0.126 moles of copper? Okay, so when I read my clues, I know that aluminum is reacting with copper 2 chloride, CuCl2, because remember the 2 goes with the charge of the copper. If this is a +2, you got to have 2 chlorides to go with. And I know I'm producing copper, and so the rest of it we'd have to have a little bit more knowledge about our equations and stuff to say what's happening is the aluminum is going to replace the copper, and we're going to form aluminum chloride. Now aluminum forms +3 ions, so aluminum chloride is AlCl3. Now I have to balance the equation. So right now the aluminum's okay and the copper's okay, but the chlorine isn't. Okay, I got 2 here and 3 there. So I'm going to balance that with a 3 and a 2. But then I have to fix my other ones, because now I got 2 aluminum, so I'm going to put 2 there, and 3 copper, so I'm going to put 3 there. Now I have a balanced chemical equation. Let's write in. How many grams of aluminum? Here's aluminum. I'm going to put X grams. I want to produce 0.126 moles of copper. 0.126 moles. Look at that. It was moles, not mass. Now, in my problem, that's my, I know that's a product, but that is the quantity I was given to start my calculation. So I start out with 0.126 moles of copper. So when I go back and look at that map, I'm already here. I'm already at moles. I don't have to do that. Okay? So what I need to do is use my mole ratio. And it says for every 3 moles of copper, I need 2 moles of aluminum. And I want copper to cross off. So 3 moles of copper to 2 moles of aluminum. There's my ratio. Moles, copper, cross off. Okay. Now, for the final answer, I was asking for mass, so I do have to do that conversion. And I look up aluminum on my table, and aluminum is 26.982. 26.982 grams of aluminum per mole of aluminum. Moles cross out, and let me go ahead and finish it. 0.126 times 2 divided by 3 times 26.982 equals 20, we only got 3 sig figs, so 20.4 grams of aluminum. All right, really, the mathematical steps are stuff that we learned already. We're adding in the mole ratio, but that's not a real big concept. So it's just a matter of putting things together. I'm going to ask you to do a couple of calculations on this. And yeah, if you have problems, let me know. I will help. Have a great weekend.